Byron Johnson here with Coordinated Power. Just going to walk you through real quick how to model a ground grid in WinIGS. We ran the basic calculations in the previous video. Now we'll just talk about how to make the grid. So we're back in the edit mode. You can see the plot frames. We're going to come up here and add whatever kind of conductors that you want. You can grab a rectangular ground mat that's a grid, and you just define the spacing in the array of how many vertical and horizontals. Horizontal ground conductor, that's the one that you'll use the most. So you come over here. Whoops. It's all under insert electrode, horizontal ground conductor. And you can draw them that way. It's assumed even if they don't touch, they're all in this group called main ground. And this is the node right here, main ground, that comes out of it and ties back into the one line model. So this is new bus A, and it's main ground. So that's an important thing to remember, is even if they're not connected, they're in the main ground group, WinIGS assumes they're somehow at the same potential. They're somehow connected. But you double click into it, and you can edit things like the depth of it. So 1.5 feet for this one just by default. You can pick your sizing of it, so on and so forth. This was a fence post array, where you can also specify the depth of the posts into the ground. So when the fence gets grounded, basically this acts like a ton of ground rods. Then over here as well, you can add in ground rods. Where are they at? Ground rod in GEM, that might be a ground well, ground enhancement material, where you drill it super deep and you backfill it with low resistivity bentonite or something similar. Same with a horizontal conductor. You can do that as well. Steel post array. Single ground rod, you put that in, give it your burial depth. And then over here is where you import your soil resistivity data. Now there's a lot more stuff that you can talk about. You can view your 3D grid layer here. You can view your math model here. Where is that? I'll have to find that later. Maybe that's in tools. I'll come back to that. But input your soil resistivity here. And we usually use the Winner 4-pole edit. And this is where you put the probe spacing. I just put a few random points in here. So at your 2.5 foot spacing, let's say we got 100 ohms, then 10 ohms at 20 and 3 ohms. Right? And then you'll update your apparent resistivity column and auto-calculate. And then you come down here and you pick the number of layers. WinIGS even has a button to help you recommend whether to go with 1 layer, uniform model, 2-layer model, or 3-layer model. Then you process it, and it comes up with the calculated upper soil layer, the lower resistivity, and the thickness of the upper layer. Then you accept that, save all this, and you're ready to run the calculations in your ground grid. Now, to get a little, you can also import from a DXF. So if you've got a DXF with you got conductors on named layers, so we don't have one for the example here, but you can import all this from a DXF. If you put things on layers, you can select a whole layer at a time. So maybe select all your 4-aught layers or all your ground rods by the layer. And there's some, clearly there's a lot of buttons here, and we don't have time to talk about all of those right now, but I think this gives you enough to at least get started modeling basic grids and get some progress on this.